to help us think about simplifying rational expressions, which is really just a fraction that involves a variable, we're going to actually begin by thinking about how we would just simplify a regular number, a regular fraction that has no variables at all, just the numbers 18 and 24. So I want you to take a moment here on your paper. I want you to go ahead and simplify that fraction down, reduce it down as far as you can go, using any method. All right, so I think a lot of times when we're looking at fractions and trying to think about simplifying or reducing it down, we think of, all right, is there something that I could divide both the numerator and denominator by? And you might have noticed that there's a lot of numbers that they could both be divided by. You could divide the top and bottom by 2. You could have divided the top and bottom by 3. You could have divided by 6. And hopefully reduced it down to the fraction 3/4. I want to show you here another way that we could have approached this, a slightly different way of writing this out. So instead of thinking of this as 18 on the numerator, we know that 18 is really 9 times 2, and 9 is really 3 times 3. So I'm going to actually write this out on top. This is like a factored form of the number 18 because we're writing it out here as a product of factors, 3 times 3 times 2. We're taking it down as far as we can go. Now, if we did the same thing here on the denominator, there's a couple of ways that we can think about getting to 24. One of those options would be like 6 times 4. If we were to break those down, 6 would be 2 times 3, and 4 would be 2 times 2. This is actually called a prime factorization because we're writing this out as a list of all prime factors, so we can't take these numbers down any smaller. So I want you to notice here that we are multiplying all of the factors together on the top. We are also multiplying our factors together on the bottom. When that is the case, so we have to have multiplication on both the top and bottom, this is where we can cancel out common factors. So let's notice here that we have like a factor of 3 on the top. We also have a factor of 3 on the bottom. Those can cancel out. That's really what's happening if you think about like dividing the top by 3, dividing the bottom by 3. We can also do that with a 2. So we can cancel out a 2 from the numerator with a 2 from the denominator. So that would be like dividing the top and bottom by 2. If we were to divide by the 3 and the 2 at the same time, that would be like dividing the top and bottom by 6. So notice that that leaves us with a 3 on the numerator, and then that 2 times 2 giving us a 4 on the denominator. So thinking about what we just did here with some canceling in the first problem, I want you to think about question number 2. So if you look at this, we have a slightly different fraction set up. Would it make sense to cancel the 3's in this fraction? Why or why not? So I want you to actually take a moment and respond to this in writing on your paper. Let's just think about what would happen in either case. So if we were to cancel out the 3's, that would leave us with 10 divided by -2. That would be an answer of -5. Well, if we were to just add across the top here, so like the 3 plus 10, that would give us 13 on the top. If we were to just do 3 minus 2 on the bottom, that's 1 on the bottom. 13 over 1 is really just equal to 13. So notice how mathematically it does not seem that that would work to cancel those 3's because the results are not the same. So it seems to be different from what we did up here in the first problem where 18 over 24 truly is the same quantity as 3/4. But that doesn't seem to be the case down here when we have the addition and subtraction. So a really key thing that we need to be aware of when we're talking about canceling from the numerator and the denominator is that we are only allowed to cancel like this when we are multiplying. multiplying in the numerator and multiplying in the denominator. So we're going to actually make a note of that. So we're going to write this off to the side here. Just a reminder that we can only cancel factors when they are being multiplied on the numerator and denominator. All right, so we're going to keep that in mind as we move forward and start to look at simplifying some expressions that involve the variable x. And so we're going to jump down here to this expression here that we have in number 3. And notice that at the very start, like it looks like we have an x squared on the numerator, there's an x squared down here on the denominator. What we want to avoid is that tendency to want to cancel these out together. Notice that we're subtracting on the numerator, we're subtracting down here on the denominator. Things are not being multiplied yet, so we're not able to cancel anything just yet. So what we need to actually do is factor. So because we have expressions like x squared minus 16, the factoring will look a little bit different from how we factor these whole numbers up above. But it's still the same idea. Factoring is getting it so that we have factors that are now being multiplied together. So we need to have this multiplication right here. That's what it means when our parentheses are touching, so that we could eventually do some canceling. We had quite a bit of factoring Monday and Tuesday, and so hopefully some of these strategies are feeling a little bit fresh in your mind. We'll be doing a lot more factoring today. So this x squared minus 16, we know that's a difference of squares, so we'll go ahead and factor that into x plus 4, x minus 4. And then it looks like we have a basic trinomial on the bottom, so we're just going to figure out what multiplies to negative 12 and adds to positive 1. It looks like here we can do positive 4 and negative 3. Oh yeah, negative 1, here we go. I moved it down there wrong. Okay, so let's do negative 4 and positive 3. That should work here. Okay, all right, so now notice that we have achieved this multiplication. So we've got multiplication now on the top. It's happening right here where those parentheses are touching. And we also have multiplication down here on the bottom where those parentheses are touching. And so that means that if we have a common factor on the top and bottom, like in this case we have an x minus 4 on the top and an x minus 4 on the bottom, we can go ahead and cancel that out. Now once we've canceled that, I do want you to go one more step, and we are going to rewrite our final answer just like this. So we would say here it would be x plus 4 over x plus 3. So that is the all the way reduced, simplified form of this fraction. Now notice that we would not be able to do anything further here. We cannot cancel the x's here, even though we have an x on the top and the bottom, because this is a plus sign on the top, and we also have a plus sign down here on the bottom. So that is as far as we're going to be able to go. Now, one more thing the question is asking us to do. So in addition to actually simplifying it down, it says, what are the restrictions on the variable? Well, this goes back to thinking about the domain if it was a rational function, meaning what are the possible values of x that are allowed to be plugged in to this function. And we've been talking all week about how when we're dealing with fractions, we need to avoid having a denominator of 0. A denominator of 0 is undefined, it is not allowed. And so what we're going to look at here is that it's kind of like, okay, if we can plug in any number for x except for two values. In this case, it would be positive 4, because that could make the denominator 0, 4 minus 4 is 0. Another one that would be not allowed is the x value of negative 3, because that would make the denominator 0. It's kind of like the values of like where the vertical asymptote would go in what we've been talking about with our graphing. And so the way we're going to show the restrictions off to the side here is very simple. We're just going to say that for this situation, x cannot be 4 or negative 3. And I'm going to put a box around that because that is going to be part of our answer. Notice that even the part that canceled out is included in what we're saying is a restriction because it was there in the original problem. Sometimes students will get their denominator factored first and then just state the restrictions right away and then go back and do the canceling and get the fraction in a simplified form. We actually did a little bit of practice with this type of simplifying on Monday when we were finding holes. So if this was something that we were wanting to graph, so we kind of had a little preview of this, we would say, oh, actually we have a hole in the graph at 4 because that's where it canceled. The only actual vertical asymptote we would have is at negative 3. All right, so I'm going to show you something here on the next page. This is what we need to avoid. So we talked about the little puppy dying like about a month ago with a different kind of common mistake. Well, this is another one that we want to avoid because anytime you do this, if you just cross out the x squared, this cute, adorable little kitten dies. So this is just a little reminder that that is sometimes a common mistake that students make on this. We are not allowed to do that. So we're not allowed to cancel only if things are being multiplied across the top and the bottom. And what we'll see in the next problem is just a slightly different way to think about factoring. And so I want to remind you here that before we try any other factoring method, we always want to check for and see if there is a greatest common factor. So let's see how that would apply up here in this first numerator. All right, so if we look at the 4x squared minus 36, notice how both the 4 and the 36, they can be divided by 4. And so that would be a greatest common factor that we can take out and put on the very front of our parentheses here. Now, when we divide a 4 out of each one, it's going to leave us with x squared minus 9 in the parentheses. All right, now the 4 is going to stay out in front here, but notice how that x squared minus 9, we can take that a step further. So that is a difference of squares, and so that'll go all the way to become x plus 3, x minus 3. All right, let's take a look now at our denominators. So we have a greatest common factor down there as well. We can divide a 4 out from the 4 and the 12, but they also have an x in common. So we can actually take out a 4x, and on the inside here, that's going to leave us with x minus 3. And we can't take that any further. I'm just going to actually rewrite that right off to the side here so that we have all of our pieces that we're looking at in the same place. All right, so now we have things being multiplied together. So I'm going to draw in, like, let's just imagine that we have some multiplication signs here across the top, and we've got multiplication here on the bottom. And there's a couple of things here that we're going to be able to cancel out. So notice that we have a 4 on top that can cancel with this 4 on the bottom. This x minus 3 over here, and the parenthesis can cancel with this x minus 3 on the bottom. All right, so all we have left with is an x plus 3 on the top and just a single x on the bottom. Now remember here, because we have that plus sign on the top, you cannot cancel the x's in this answer. That's as far as we can go. We're just going to leave our answer as it is. Now throughout the day, we're still going to be continuing to do the restrictions. And so let's go ahead and make note of that here. We're going to go back to looking at our denominator before anything cancels. In this case, the restrictions that we're looking at are only based on the factors that involve an x. So you can actually ignore that 4 out in front. That's not going to have any effect on what the restrictions are, because that 4 is not going to cause the denominator to be 0. But if x is 0, like on this one here, that would make a denominator of 0. Or if x was positive 3, that's another way that the denominator could be made 0. So there's that final part of our answer. All right, so we've done a couple of examples together here. I'm going to give you guys a few minutes. I want you to go ahead and try the next one on your own. So we have a basic trinomial on the numerator. We've got a basic trinomial on the denominator. So I went ahead and just wrote those out, what it would be in factored form. So on the first one, we wanted it to multiply to negative 8 and add to positive 2. Down here, we want it to multiply to positive 6 and add to negative 5. So that's where we get our parentheses filled in. So before we think about doing the canceling, so I want to model for you how you could do things in a little bit different order. You can look at your denominator to get your restrictions right now. So you don't always have to wait until the very end. So I'm going to do a little something here. We are going to ignore the numerator when we get our restriction. So the restriction is just what would make it undefined. What x value could make the denominator 0? And so because we have 2 pieces here on the denominator, we are going to have 2 restrictions. So the first one is going to be that x cannot be positive 2. And that's corresponding to the x minus 2. It's kind of like, so if you set x minus 2 equal to 0 and solve for x, we get positive 2. And that makes sense because if you plug positive 2 in right here, 2 minus 2 is 0. And then 0 times anything is 0. So that's a problem, because it's going to make our denominator 0. Let's do the same thing over here on this one. So x minus 3. If we set that equal to 0 and solve for x, we're going to get positive 3. So that's going to be the other restriction. So you can actually get those restrictions as soon as you've done your factoring, only based on the denominator. Okay, let's see. So let's go ahead and bring back those numerators, because we do need those in order to do our canceling. So notice that we have an x minus 2 factor on the top, as well as an x minus 2 factor on the bottom. It is okay if they're not in the exact same position. Like it's okay that this is at the end and this one is at the beginning, as long as it's somewhere in the realm of what's being multiplied on the top and bottom. Also, in order for us to cancel this out, what's in the parentheses has to be exactly the same. So, for example, if you had x minus 2 on top and you had x plus 2 on the bottom, we would not be able to cancel those. They're not exactly the same. So those are going to go away, and that's going to leave us with our final fraction simplified answer, x plus 4 over x minus 3. All right, so we're going to start off in kind of a similar way that we did before when we were just simplifying. When we're taking a look now at multiplication, we're going to look at a way that we can multiply just regular numbers. So we're not going to put any variables or any x's into this yet. So when we're multiplying with fractions, like one way that we can think about this is to multiply straight across the numerator, multiply straight across the denominator, and if we're able to simplify our resulting fraction, we can go ahead and do that. All right, so here's a slightly different way that I want to show you for how we could write this out. So we could actually think about doing a little bit of factoring within each fraction separately, looking to see if we have any factors that can cancel, and then multiplying across the top and multiplying across the bottom. So it's kind of like simplifying this down a little bit along the way before getting to the final answer. So let's look at this 18 over 5. Now, we don't have to go all the way down to the prime numbers like we did before. You could do that. You could do 3 times 3 times 2. But because of what I see in the other denominator, I'm just going to simplify that down to be 9 times 2. So that's a different way of representing that same first fraction. And then I'm going to think about the same thing over here. So looking at that second numerator of 10, I'm going to go ahead and factor that into 5 times 2. Now, here's the cool thing. So because the process of multiplying a fraction by a fraction is really just multiplying across the top and multiplying across the bottom, watch this little trick here. I can actually extend this fraction line all the way across to make it one big fraction. Put in a little multiplication sign right there between the 2 and the 5. Put in a multiplication sign down here between the 5 and the 9. So now thinking of this as one big fraction, we have now turned it into something exactly the same as what we did on the first page. Because things are being multiplied across the top and multiplied across the bottom, we can go ahead and cancel out common factors. So we've got a 9 on the top. That's going to cancel with a 9 on the bottom. The 5 on the top can cancel with the 5 on the bottom. Notice how the only thing that leaves us with is 2 times 2, and we do get to that same answer of 4. All right, let me actually pause here on the notes page for just a moment. So I was just thinking about this as we were just canceling those out, and I want to just make a note that, like, so if we had a fraction, like let's say we had something like a 5 times 2 on the bottom, and let's say that we had a 3 times 3 on the top. In this case, even though we have 2 3's, we could not cancel them. We can't cancel the 3's in this case because they are in the same position, like they're both on the top. And so let's just be mindful of that. The only reason that this canceling here is working, what we just did, is that one is on the top and one is on the bottom. So that's just helpful to remember. All right, so that means when we transfer this to like a more complex multiplication problem with rational expressions, it's kind of just the same thing that we did on the front side. We're just doing it for like 2 fractions and just going to be a little bit more factoring, but really we can think of it as being like one big fraction. So let's try that for this problem here. I'm going to start by just rewriting the first fraction by getting it all factored. So the numerator here is a basic trinomial, so that can factor into x minus 2 times x minus 1. The only thing we have on the denominator is a greatest common factor of 3. So we can go ahead and factor out that 3, leaving us with x minus 2 in the parentheses. Then in the second fraction, we have a difference of squares. So we can factor that into x plus 6, x minus 6. And then we have another basic trinomial on the bottom. And we want this one to multiply to negative 6, but we want it to add to positive 5. So on this one here, let's do positive 6 and negative 1. All right, so here's what we can do again. So because we're multiplying these, we can extend that fraction bar across, and we can just think of this as one giant fraction. Before we do our canceling, we're still going to do our restrictions for these problems, and so we can actually take a look at doing that now. Sometimes it's easier to do the restrictions before you cross things out. So from that x minus 2, we know that x cannot be positive 2. We're only going to be looking at the denominator here, just the factors that involve an x. So from the x plus 6, we've got a restriction here, x cannot be negative 6. And then from this x minus 1 down there, we have a restriction that x cannot be positive 1. So that greatest common factor of the 3 out in the very front, that actually has no effect on making the denominator 0. We don't need to think about that or do anything with it when we're getting our restrictions. All right, so now that that's out of the way, what are some things you see here that we can cancel? What do you notice?
X, both on top and bottom, x minus 2, x plus 6 is x minus 1.
Awesome. Okay. Oh, it's always fun when there's a lot of things that cancel out. And so we'll go ahead and cross those out. And the only thing we're left with here is we just have x minus 6 divided by 3. There's nothing else that we can do there to simplify that fraction. Do not try to do negative 6 divided by 3. We can't do anything with that because we have that x with that minus sign out in front. So just leave the answer just like this. Okay, so the multiplication is not too much more difficult. It's really just looking at one giant simplifying problem. All right, we are going to finish up by looking at a division problem, and this process is going to be a little bit. All right, so now let's finish up the division. So we're going to start again by just looking at regular numbers. So we've got 3/5 divided by 2/7. So when we divide by a fraction, the process that we want to follow is keeping the first fraction the same. That division sign is going to turn into a multiplication symbol, and then we're going to take the reciprocal of the second fraction. So the second fraction, numerator and denominator are going to flip. They're going to switch places. So dividing by 2/7 is really the same thing as multiplying by 7/2. And so it's just this one extra little step at the very start that turns it into a multiplication problem, which we already know what to do if it is multiplication. And so the phrase that I like to think about to help remember what to do here is I call this copy dot flip. So copy, meaning I'm just going to recopy the original fraction. The dot part here means that we're going to turn that division sign into multiplication. And the flip means we're taking the reciprocal. So we're flipping the second fraction, the numerator and denominator change places. All right, so here's how that would look if we were to apply that to a division problem with rational expressions. Let's try the copy dot flip. So copy, so we're going to keep the first fraction exactly the same. All right, and then for the dot part, we're just going to turn it into multiplication instead of division. And then for the flip, that's only going to apply to the second fraction. So we're going to do the reciprocal. So the 5x plus 10 is now going to go on the numerator. And the x squared plus 8x plus 15 is going to go on the denominator. That is the only different thing we have to do when it's division. Otherwise, it's going to work out the same way. So I'm going to give you a few more minutes on your own to try this one. So since we have just now turned it into a multiplication problem, it's similar to that one that we just did. All right, so I'm just going to start to write up here what this first step of the factoring should start to look like. So it looks like we have a difference of squares on that first numerator. We just have a greatest common factor on the first numerator. We have another greatest common factor over here. I'm sorry, I didn't say denominator. The 5x plus 10, turn that into 5 times the quantity x plus 2. And then it looks like here we've got x plus 5 multiplied by x plus 3. Okay, so because it's multiplying here, I'm going to do the trick. We're just going to extend that fraction line across. Think of it as one giant fraction. Now, before we do our canceling, this is where we can actually pause here and just think about listing out those restrictions. And so when we take a look at everything that is currently on our denominator, we've got an x minus 3, an x plus 5, and an x plus 3. So we're going to want to say that x cannot be the value that would make each of those quantities equal to 0. It's going to look like it's changing to the opposite sign of what we have in parentheses. So for the first one here, x cannot be positive 3. For the blue one, x cannot be negative 5. And for the green one over here, x cannot be negative 3. There is, however, one more thing that we need to think about with the restrictions when we do our division problems. I'm going to highlight one more piece that is going to be part of our restriction, and that is this x plus 2 that we had in our second numerator. So I'm going to add that to the list. So I'm going to say x cannot be negative 2. This came from the 5x plus 10, and even though the 5x plus 10 is on the numerator, when we flipped it, the 5x plus 10 used to be on the denominator in the very original problem. And so the only reason that we would ever look at something for a restriction that looks like it's in a numerator is because it used to not be in the numerator. So let's make a note of this here, that we are going to include that in our restrictions. I'm just going to say here because this was in the original denominator. So right here in the very beginning of the problem, if we were to do a little factoring at the very, very start, we see that x plus 2 is in the denominator. So this is going to include every possible value of x that would have made the denominator 0 at any point along the way, including at the very, very beginning. All right, so that's a little something new that we need to know for restrictions. So I'm going to circle that. That's part of our answer. Let's go back over here then and start to see what can cancel. So it looks like we have an x minus 3 that cancels from the top and bottom, and an x plus 3 that can cancel from the top and bottom. That is leaving us, we have some leftovers here. So we're left with 5 times x plus 2 on the top, and then we have 4 times x plus 5 on the bottom. You can leave it like that, or you could distribute the numbers in. So you could have said 5x plus 10 over 4x plus 20. Do not attempt to do anything else here. There's no more canceling or simplifying that we can do. That's as far as we can go. So this is part of our answer because that's our final simplified fraction. And then the restrictions here are also part of our answer.